on basic electronics. The course code is 23 ECT 23B. So we're discussing about module 4, that is fundamental electronics, fundamentals of digital electronics. So the content of this module goes like this: like digital computers and digital systems, binary numbers, number-based conversion, octal and hexadecimal numbers conversion, axiomatic definition of Boolean algebra, basic theorems, properties of Boolean algebra, Boolean functions, canonical and standard forms, the other logic operations, combinational logic introduction to adders and so in today's session we'll discuss about the canonical forms, or we say that it's a standard forms. So we'll get four Boolean product terms by combining the two variables x and y with logical AND operation. These Boolean product terms are called as minterms or standard product terms. The minterms are x dash y dash, for example, x dash y, xy dash, and xy. Similarly, we'll get four Boolean sum terms by combining the two variables x and y with logical AND. Similarly, we'll get four Boolean sum terms by combining two variables x and y with logical OR operation. These Boolean sum terms are called as max terms or standard sum terms. The max terms are x plus y, x plus y dash, x dash y plus x dash plus y, and x dash plus y dash. So here we have a table which indicates the min terms and the max terms. So we have two variables x and y. The inputs are x and y. So here the two inputs goes like this: 0 0 0 1 1 0 1 1. M naught is equal to x dash y dash. M1 is equal to x dash y. M2 is equal to xy dash. M3 is equal to xy. And the max terms are m naught is equal to x plus y, m1 is equal to x plus y dash, m2 is equal to x dash plus y, m3 is equal to x dash plus y dash. So if the binary variable is 0, then it is represented as complement of a variable in minterm and as the variable itself in the max term. Similarly, if the binary variable is 1, then it is represented as complement of variable in max terms and as the variable itself in minterm. From the above table, we can easily notice that minterms and max terms are complement of each other. If there are n Boolean variables, then there will be 2 power n minterms and 2 power n max terms. So coming to this canonical SOP and POS forms, a truth table consists of a set of inputs and outputs. So if there are n input variables, then there will be 2 power n possible combinations with zeros and ones. So the value of each output variable depends on the combination of input variables. So each output variable will have 1 for some combinational input variables and 0 for some other combination of input variables. Therefore, we can express each output variable in following two ways. One is canonical SOP form and the other one is canonical POS form. Canonical SOP form means sum of products, that is canonical sum of products. In this form, each product term contains all literals. So these product terms are nothing but the min terms. Hence, canonical SOP form is also called as sum of minterms form. So first identifying the minterms for which the output variable is 1 and then do the logical OR of those minimum terms in order to get the Boolean expression that is corresponding to the output variable. This Boolean function will be the form of sum of minterms. So same procedure is followed for the other output variables also if there is more than one output variable. Now let us consider the following truth table. So here the output is 1 for 4 combinations of inputs. The corresponding minterms are P dash QR, PQ dash R, PQR, PQR. By doing logical OR of these 4 minterms, we will get the Boolean function of output. Therefore, the Boolean function of output is f is equal to p dash qr plus pq dash r plus pqr dash plus pqr. This is the canonical SOP form of output. We can also represent this function in the following notations. In one equation, we represented the function as sum of respective minterms. In other equation, we use the symbol for summation of those minterms. Canonical POS form. So here canonical POS form means canonical product of sums form. In this form, each sum term contains all literals. So these sum terms are nothing but the max terms. Hence, canonical POS form is also called as product of max terms form. So identify the max terms for which the output variable is 0 and then do the logical AND of those max terms in order to get the Boolean expression. Corresponding to that output variable, this Boolean function will be in the form of product of max terms. So follow the same procedure for other output variables also if there is more than one output variable. So if we consider some example like considering the same truth table which we have seen. So in the same truth table for the max terms will become p plus q plus r, p plus q plus r dash, p plus q dash plus r, p dash plus q plus r. So by doing logical AND of these 4 max terms, we get the Boolean function of output. Therefore, the Boolean function of output is f is equal to, it's a product of sum like p plus q plus r into p plus q plus r dash into p plus q dash plus r into p dash plus q plus r. This is the canonical POS form of output. We can also represent this function in following two notations. In one equation, we represented the function as product of respective max terms. In other equation, we use the symbol for multiplication of those max terms. The Boolean function f is the dual of the Boolean function of minterms. Like the Boolean function for sum of products is the dual of the Boolean function for the product of sums. Therefore, both canonical SOP and canonical POS forms are dual to each other. Functionally, these two forms are same. Based on the requirement, we can use one of these two forms. So coming to the standard SOP and POS forms, like so far we discussed two canonical forms. Of representing the Boolean output. Similarly, there are two standard forms of representing the Boolean output. There are two standard forms of representing the Boolean output. Like these are the simplified versions of canonical forms. Like one is standard SOP form and standard POS form. We will discuss about the logic gates in later. Like first we'll discuss the main advantage of standard forms is that the number of inputs applied to logic gates can be minimized sometimes. There will be reduction in the total number of logic gates required. So standard SOP form means sum of products form. In this form, each product term need not contain all literals. So the product terms may or may not be the min terms. Therefore, the standard SOP form is the simplified form of canonical SOP form. So we will get standard SOP form of output variable in two steps. Like get the canonical SOP form of output variable, simplify the above boolean function which is in canonical SOP form. So follow the same procedure for the other output variables also. If there is more than one output variable, sometimes it may not be possible to simplify the canonical SOP form. In that case, both canonical and standard SOP forms are same. So in this, if I say that someone the standard SOP form is f is equal to it goes in equation like p dash qr plus pq dash r plus pqr dash plus pqr. So in this boolean function, it's in canonical SOP form. So we have to simplify this boolean function in order to get the standard SOP form. So using the boolean postulates like express x is equal to x. So that means logical OR operation with any boolean variable n times will be equal to the same variable. So we can write the last term PQR two more times, and using the distributive law for the first and the fourth terms, we can write like P dash plus P, Q dash plus Q, R dash plus R. So using Boolean postulates, x plus x dash is equal to 1 for simplifying the terms present in each parenthesis, and also using the Boolean postulate, that is x into 1 is equal to x, for simplifying the three terms. F is equal to qr plus pr plus pq. F is equal to pq plus qr plus pr. So this is a simplified Boolean function. Therefore, the standard SOP form corresponding to standard SOP form corresponding to given canonical SOP form is F is equal to PQ plus QR plus PR. Similarly, for the standard POS form, the standard POS form means standard product of sums. In this form, each sum term need not contain all literals, so the sum terms may or may not be the max terms. Therefore, the standard POS form is the simplified form of canonical forms. So we'll get the standard POS form of output variable in two steps. Like following the same procedure for other output variables also, if there is more than one output variable sometimes, it may not possible to simplify the canonical POS form. So in that case, both canonical and standard POS forms are the same. The simplification is also same for the standard POS form. So here the Boolean postulates and the theorems are used. So here in case of POS, the postulate x into x is equal to x is used, and the distributive law is used. The other Boolean postulates like x dot x, x into x dash, x and x dash is equal to 0, and x or 0 is equal to x. So these are some of the postulates that can be used. So basically, SOP stands for sum of products, POS stands for product of sums, and it's a technique for defining the Boolean terms as the sum of product terms, and it's a technique of defining Boolean terms as a product of sum terms. And what is the difference between SOP and POS? SOP stands for sum of products, POS stands for product of sums. So it's a technique of defining the Boolean terms as the sum of product terms. It's a technique of defining Boolean terms as a product of sum terms. So SOP, it prefers min terms. POS, it prefers max terms. So SOP, in the case of SOP, the min terms are defined as M. In case of POS, the max terms are defined as capital M in caps. So it gives high output, it gives low as output. So in case of min terms, high is the output. In case of max terms, low is the output. So in SOP, we can get the final term by adding the product terms. POS, we can get the final term by multiplying the sum terms. So this is the difference between SOP and POS forms. Thank you.